Good afternoon and welcome to our STAAD Special Interest Group session, our first one of 2021. Let me go ahead and introduce myself. My name is Sabrina Tedeschi, and I'm going to guide you through the process for understanding loads in the STAAD.Pro Physical Modeler today. Just to give you a little background on myself, I am a structural engineer, and I've been with Bentley Systems for over 12 years, and I conduct training courses and create training programs for all of the products within our RAM and STAAD product lines. Before working for Bentley Systems, I did work in the industry for an architectural engineering firm where I designed large commercial structures out of a variety of materials, including steel and concrete. Now, before we dive into our topic today, let's give you a brief overview about what to expect in a STAAD Special Interest Group session. I want to give you a few reminders about why these sessions are scheduled, what the advantages are to you, and when you can expect the next one to be. So today's session is at 1 p.m. Eastern Time. I looked up on the internet and I figured out that that is at 6 p.m. Global GMT time. So if you're not in the United States or not in the Eastern time zone of the United States, you can expect these sessions at whatever time it is now. We typically conduct these sessions for STAAD on the third Thursday of each month. We do take 2 hiatus months a year, so you can expect 10 of these sessions from the U.S. colleagues each calendar year. We do have special interest group sessions that are more designed for an international audience as well, and I'll show you where you can register those. We'll do a little brief overview at the end of this session so you can kind of be aware of all of the resources you have available to you at Bentley Systems. Now, we do record all of these sessions, and some of them are available on the Bentley events page. Some previous ones, mainly our 2020 Special Interest Group sessions, and anything before that and anything from here on out will be placed on the Bentley Learn server. Again, I'm going to go ahead and give you an overview about where you can find that collateral in case there are some sessions that are of interest to you that you were not able to attend live, but you'd like to review them at this point. Now, we do provide a PDH credit, which will be available on your Bentley transcript after this session. We will be sending a follow-up email, which will also provide you instructions in case on the off chance anybody is watching this with other colleagues, but only one of you have logged in. Please go ahead and let us know who else from your organization is reviewing this presentation so we can make sure that their transcripts are updated. Again, you'll get an email on that after today's session, and your Bentley transcript can be found from the Bentley Learn server. Again, I'll go over that at the end of this session. For more information, you can always contact the Bentley Institute at bentley.institute@bentley.com. And then as a reminder, special interest groups are complimentary. You can go ahead and sign up for as many of them as you are interested in. And again, I'll go over some of the different options for finding out where that collateral is through the Bentley website at the end of this session. Now, today's session is being presented through WebEx. This happens to be my first time using WebEx, so I hope you are understanding if I'm slightly clumsy on this first time. Now, the way this session works is I'm going to primarily spend the first, I would say, 3/4 of this session doing a presentation on my predefined topic, which for today would be discussing different load options that are now available in the STAAD.Pro Connect Edition in the Physical Modeler. Let's go ahead and turn our attention to our agenda today, which is understanding loads in the STAAD.Pro Physical Modeler. I have several different discussions that I'm going to be focusing on in today's session. So let me give you a kind of overview about what I envision us to be able to cover or discuss in today's session. Our first discussion is going to be on the topics of load cases and load groups within the physical model. We're going to talk about the difference of those and how to understand they're going to be translated over to the analytical modeler. We're going to also talk about the traditional load combination options or repeat load cases in the physical modeler and how to control your load combination generation. Now, I did just discuss a detailed breakdown of the different load combination types that we have available in STAAD.Pro in the previous special interest group session. So this will be a broad overview of those topics, but I'm going to add in a few extra things that I did not cover in that session. And again, I'll show you where to find that session in case you missed it and would like to review. And then lastly, we're going to turn our discussion over to code loads, the traditional things that we would use a load definition for in STAAD.Pro, including seismic code loads and also wind code loads. I'll basically share with you what's available at the present time, where we see this going also in the future. Now, we won't be going too much in detail about all the options or the full workflow for each of these. This is more discussion-based. That's the focus of our special interest group session today. My goal is to basically convey the types of loads that are available so you can understand when you make that decision about whether or not you're going to go with a physical modeling workflow or an analytical modeling workflow, what's available in each area of the program so you can make the best decision about which workflow is appropriate for you. I'm also going to give you some hints and some focus on some tools that are available in the physical modeling workflow that are not necessarily available in the analytical modeling workflow. And the reason I'm going to discuss those in a little bit more detail is because they might be a little bit newer to you, and some of them are kind of cool. Okay. Now, if you're interested in a more detailed workflow-based session, I would basically recommend that you would be encouraged to become an active learner through the Bentley Learn server. Through our training classes, we give a very detailed workflow-based step-by-step approach to how to incorporate all of these things. We are in the process of creating a full modeling learning path for the STAAD.Pro Physical Modeler, and I expect that to be live very soon, probably within the first half of 2021. And again, I'm going to point to that session at the end of this location, but if you see anything here today that is of interest to you, you want a little bit more detailed step-by-step approach to learn how to do it, I'm definitely going to encourage you to become an active learner through Bentley Systems. Now, before we hop into the program, let me give you a brief overview of the Physical Modeler, since some of you, this might be a newer workflow for you. So the STAAD.Pro Physical Modeler is a user interface for modeling structures using physical concepts in STAAD.Pro Connect Edition. Some of the loading features that I will be discussing in today's session are only available in the latest version of STAAD.Pro, which at this moment is STAAD.Pro Connect Edition version 22 update 5. So if you see anything, especially once we get into the things like wind and seismic that are of interest to you, I definitely encourage you to download that latest edition, as the physical modeling workflow is constantly evolving and improving on itself. Now let's also discuss physical modeling versus analytical modeling approaches. So in previous generations of STAAD.Pro, basically V8i and earlier, as well as many other analysis software products, modeling of a structure began with nodes. Then the nodes were connected with linear members and plate elements, thereby creating analytical members. Now the STAAD.Pro Physical Modeler takes advantage of physical modeling to simplify the modeling of a structure, which in turn more accurately reflects the process of building a model. Beams and surfaces are placed in the model on the scale for which they would appear in the physical world. For example, a column may span multiple floors, and a surface represents an entire floor of the building, and you can create that type of geometry in the physical modeler. When the time comes, however, for the analysis of the structure, the analytical model will be generated automatically from the physical model that you created. Surface entities will be meshed into plate elements, and the beams will automatically be subdivided for analysis as necessary by intersecting members. So as far as the workflow goes right now, you would use the STAAD.Pro Physical Model to create your model. You would create it for your surfaces or plate members. You would use it to model your beam members and your nodes. You would assign properties, create loads, load combinations, and load items within the physical model. In the analytical model, once that is created, you will then perform your analysis and design as you always had done in STAAD.Pro. Now let me go ahead and turn our attention to our STAAD.Pro interface. And what we're going to be focusing on today is we're going to be focusing on a model that I've basically already created. As I mentioned, today's format is a little bit more discussion-based. So we're going to be reviewing some information and navigating through the graphical user interface. And again, I'm going to point to some capabilities and some tools that might interest you. So as you can see, I've already created my physical model in STAAD.Pro, and it's already broken it down to an analytical model so far. The steps of the workflow that will be performed in the physical modeler will be basically everything from geometry through the loading page, and then analysis and design are still performed here. So if I went to analysis, you would see my model contains analysis commands that will be unaffected by the physical modeler, and my model also contains design commands. Now, while we're in these particular areas within the analytical model that is taken from the physical model, you're going to notice that a lot of our tools are grayed out because for a physical model, those types of things should be created in Physical Modeler. For that reason, anything from geometry through loading will also be grayed out in the input file, as those pieces of information are automatically generated from your physical model. Now at this point, let me go ahead and turn our attention over to the Physical Modeler. Okay, so here we are in the STAAD.Pro Physical Modeler. And what I'm going to start with is an explanation of, let's go ahead and navigate through certain areas within the graphical user interface. So the way the graphical user interface works is we have a ribbon toolbar at the top of the screen which has all of your tools hopefully organized in a manner that would make most logical sense for you. Now as you access different areas of the program, you can also manipulate your model through the spreadsheets over in the data area at the right-hand side of the screen. The way you're going to navigate through different spreadsheets in the Physical Modeler is you're going to go to the Spreadsheet tab in the ribbon toolbar, and here's all the different spreadsheets. Now, none of the tools in this tab actually perform any operation. What these are going to do is you're going to access the spreadsheet that you're most interested in using at that particular moment. Now this brings us to our first discussion of today's session, which is the difference between load cases and load groups. If I were to take a look in the Spreadsheet tab of the ribbon toolbar, I can see I have two different options for creating load cases. I have an option for load cases and an option for load groups. Now when I talk about load cases within the Physical Modeler, what we're basically talking about is the cases that are going to be used to create your primary load case details. So if we remember what the load and definition dialog looks like in the STAAD.Pro Analytical Modeler, these would be the primary load cases that are in the load case details list. As you can see for this particular model, I've already created 3 load cases. As a courtesy, whenever you create a new physical model, they'll give you a load case, which I usually just rename to dead load. So that's what I did here. The program automatically gave me the first load case. I changed it to dead load and gave it a category of dead. As you can see, I can manipulate things directly through the spreadsheet, or I can use the tools within the ribbon toolbar. Now the categories work the same way they would in the STAAD.Pro Analytical Modeler, where by setting the categories you will be able to include this in load combinations later on. Now within this load cases spreadsheet, I can also scroll on over and see the self-weight multiplier. I've applied a self-weight multiplier for the dead load case in the negative y direction. So this is basically invoking my self-weight option. I just saw a question that someone might be asking about reference load cases. I'm going to get to those within the next step, so stay tuned. We will be adding that in. So here for my particular model, I've included some dead load, some live load, and some snow load. I've applied the self-weight to the structure through the dead load case. So these are going to be primary load cases once I get over to the STAAD.Pro model. In addition to that, we can also create load groups within the STAAD.Pro Physical Modeler. The load groups will be basically considered as reference loads once you get over to the analytical modeler. So up in the, again, if we remember what the load and definition dialog looks like in the STAAD.Pro Analytical Modeler, these will be in the definitions area under reference loads. As you can see for my particular model, I already created one reference load case, and I used it to define my mass of my structure. Now the advantage about creating your mass on your structure, just as an aside, is that when you create the mass of your structure, that mass reference load case will be able to be used by multiple areas of the program, including considering your static self-weight for static seismic loads. It can also be used to consider your seismic mass. It can also be used to determine what the dynamic mass of the structure is for a dynamic seismic load. It can also be used to calculate the center of mass of any floor system if your model does contain a rigid diaphragm. Now I started my mass reference load case by adding the self-weight multiplier. Typically when we create something like seismic mass, we apply all of our mass of the structure in their absolute value format to ensure that they are able to be added together effectively. So now how did I go about creating these? Now that I've navigated the information that is already available in this model, let's go back to the Model tab in the ribbon toolbar. Now the Model tab, the way I like to think of this tab is this is the tools that I use to create my geometry. So spreadsheet tools, I navigate the spreadsheets in the data area. Model tab, I use this to create my geometry or to define pieces of information within my structure. So you can see here if I was creating that information from scratch and I did not want to create it directly in the spreadsheets, I can use these tools to create a load group or a load case. Now that we have gone over that information, let's go ahead and take a look at the different types of objects we can have in our physical modeler and the different loads that are available. And again, most of this is already present in my particular model. So the different types of entities we can have, or main entities that we can have within the physical modeler, are nodes, members, and surfaces. When your analytical model is created, your surfaces basically become a mesh of finite elements. So with those three main types of systems, you can add basically the same types of loads that you would in the analytical modeler. We have nodal loads, we have member loads, and surface loads, and all of these work the same exact way they would in the analytical modeler. You can enter any of these loads with reference to the global coordinate system. You can enter them in any units that you need, and most of them, say for example, some of your member loads would reference the starting end of your member very similarly to how those types of loads work in the analytical modeler. The new type of system that you might not be as familiar with, but it is available in the physical modeler, is basically panel loads. Now, when you create a panel within the physical modeler, you're not creating any type of structural entity that's adding any stiffness or any weight itself to the system. No self-weight will be associated with a panel load. It's just a way for you to create a surface load and have the model automatically distribute it to the supporting members. So you're basically going to add a panel within a bay, and then that load is going to be distributed. The load can be distributed based on a one-way or two-way distribution, and I think of this load as the same type of load system as, say, a floor load in the analytical modeler, where we can distribute that load to the supporting members, and you can go ahead and enter it in terms that you've probably defined a surface load as far as your engineering project goes. Now, the way any type of system would work within the analytical modeler is you're going to go ahead and attach information. You may need to add information to your model using a select and apply rule. Now, what does that mean? It means you select the entities and then apply them to your system. Now, the cursors within STAAD.Pro Physical Modeler work a little bit different than the analytical model. Basically, your mouse buttons work exactly the same way. So the way the cursor works is you can go ahead and draw a fence around the entities you want, but you don't have individual element type of cursors. So you can see here, if I draw a fence around my entire system, it selects everything: nodes, surfaces, panels, members, and so forth. So we don't have individual cursors available here, but I actually kind of like that. I like to be able to just fence everything and then have the option to manipulate whatever it is I'm working on. Now you're going to notice when certain types of entities are selected, your tabs within the ribbon toolbar will become available to help you manipulate or add information to those types of systems. You can see I have 4 types of systems that I previously described. Now before we go ahead and dig down deeper into the loads, let's also see how to view the loads on our screen. If we go to the View tab in the ribbon toolbar, you can see that I have a load pull down list. So in here I can see the simple load cases that I have created. So right now we're just going to focus on seismic mass, dead load, live load, and snow load. I'll get into some of these other options in a few minutes. So let me for now go ahead and navigate to the dead load group, and I'm going to ask the program to display my loads. So here you can see in the dead load group I have already created some nodal loads and some member loads on my system. So how do I review that through the spreadsheet? Let's go to the Spreadsheet tab in the ribbon toolbar. If I wanted to take a look at the nodal loads, I can go to, here's my node spreadsheets, and I go to the one that indicates point loads and point moments. As you can see through the data area, I could either use the tools on the node tab, or I can enter some information directly in the spreadsheet. Say if I want to manipulate this data, I would probably go to the spreadsheet. And then the same holds true for members. I'm going to go to the members and then the loading area. I have several different load spreadsheets available for members since there's a lot more capabilities there. So let me go ahead and show you some of the tools that I find a little bit more unique to the STAAD.Pro Physical Modeler. And the first option I'm going to show you is basically how to copy loads from one load case to another. This is a little unique for the STAAD.Pro Physical Modeler, although if I have any RAM Elements users in here, you might have used a similar tool in that product. So what I'm going to do when I want to copy loads from another load case, the first thing I'm going to do is I'm going to go ahead and select the load case that I'm currently working on. And for me, I'm going to work on, let's go ahead to my View tab. Let me go to my live load group. You can see this load group is completely empty. I've created a load case, it has nothing in it. Now I happen to know that the loads in the live load group are very similar to the loads I have in the dead load group, however their magnitudes are slightly different. So what I want to do is instead of going through that process twice where I select my members and select my nodes that I want to assign loads to, I'm going to say grab my dead loads and assign them to the live load group. I'm going to go to the Model tab in the ribbon toolbar, and I'm going to tell the program I want to add loads from groups or other load cases. So what are the load cases that are available? Load cases, which are your primary load cases, or load groups are available. I'm going to grab my loads from my dead load case. I'm going to finish this off by clicking OK. And you can see here I'm still viewing my live load, and now I have nodal loads available. Now that I have nodal loads available, I can go ahead and use the spreadsheet tools to basically manipulate this data for myself. So let's go to the appropriate spreadsheet, and I'm already there. And you can see here I have all the nodal loads now available. And say, for example, that this load is similar but not exactly the same. So I want to change it from -5 to -8 in the global Y direction. I'm going to change one of the fields. Click in the field I changed, and then this will allow me to use some of the data tools. Here I can find several different spreadsheet tools. I'm going to show you how to use a couple of these today since these are very unique to the physical modeler. Now I've made my change, I'm in the field I changed, and then I want to change all the rest. So I can just go ahead and say fill column, and then for all my FYs have been adjusted to wherever my cursor was, which was -8 kips. Okay. Again, I can go through the process that I did for the dead load, but this will make it a little bit easier for myself to change. I can do the same thing for the member loads. Let's go to our appropriate spreadsheet first. And I'm working on distributed loads. Now here again, I can scroll on over. I can resize this window if I wanted to. And for what I'm going to do in this example is I'm going to go ahead and change the top one again. I'm going to do -0.03. I like to enter, go back up. You can see the one right here that I just changed, and then I want to change all of them. So I go back to the data, and then I say fill column. Okay, and I can repeat that process. Distributed loads, you're going to repeat 2 values because you're allowed to enter the magnitude at the start of the load versus the magnitude at the end of the load. Okay. A few of these are also pretty helpful. You can definitely click in a field and tell the program you want to filter, like find and select. And then fill selection works slightly differently than that one. For that one, you would basically make a selection, and then anything highlighted in blue would be a candidate for updating. Now, in addition to that, I'm also going to use some of these spreadsheet tools in order to basically populate my mass load. You can see here I've already added the self-weight vector using the absolute value in the X, Y, and Z directions. And now again, those loads are going to be very similar to my dead load. So I can copy primary load case items to a load group as well. And of course, our process for that starts with activating the load that we're working on. Again, this load is currently empty. I'm going to go to the Model tab in the ribbon toolbar. I'm going to tell the program I want to add loads, and I'm going to add them from the dead load case. Okay. Now again, I want to enter my masses and their absolute value in the 3 global axis directions. So this got me almost there. I would say about halfway there. Now I want to get the rest of the way there by using the spreadsheet tools. So I'm going to go to the spreadsheet option. Let's start with nodal loads again. And here we have it. Now, what I want to do this time is I want to go ahead and say, well, I want this, but I want its absolute value format. I'm going to go to the data area. I can go ahead and enter a value of -1. I basically want to multiply every single one of these cells by -1. And if I just hit the multiply option, it turns that from a negative to a positive. I can also highlight that area, click copy, and then I can click paste to move it to the global X direction and also the global Z direction. So that was a very quick and easy way for me to populate my mass point loads. Member loads gets slightly more challenging just because each member load is only allowed to be entered in one global axis direction at a time. So here what I'm going to do is I'm going to go ahead and grab the fields that I'm interested in, and these will be in the global Y direction. So I'm going to go to my data tab and multiply those by -1. Then if I want to complete that off, the best way is to select the members I want to assign it to, and then I can go to the member tab. Now when you go to the member tab, you can see all those different options. The same would hold true for the node tab, the panel tab, and the surface tab as well. So here I just want to create a distributed load. I'm in seismic mass. You'd always want to select your appropriate load case. Here you're going to get all your different load options. And I'm going to enter the global axis direction. I'm going to start with the X. I need X and Z now. And I'm going to enter it as 0.02 kips. We will click OK. And then I'm going to repeat that process. Now, one of the nice things about the physical modeler is most of the dialogues will retain what you previously entered, so I only have to focus on the fields that I need to change. Go ahead and click OK. So let's go through the different options for loads and make sure we know where to find them when you're creating them from scratch, and hopefully you learned how to use this spreadsheet a little bit more, because I think there's a lot of potential for creating geometry through that area. So here you can see I have the entire model created. If I go to the node tab, I can find its load types. The member tab, which we've already played around with, I can find the load types. And then for the surface area as well. And several of these surface type loads are the same as our plate loads in the analytical modeler. The last type of system, which might be newer for you, is to create a panel. So let's go ahead and go to the Model tab of the ribbon toolbar, and you can see here I use this tool to create my panels. You're going to create them the same way you would create any plate or any surface in your model. You're just going to click the nodes within each bay in consecutive order. It doesn't matter clockwise or counterclockwise, as long as you go around the perimeter of where your panel will be placed. Once you place a panel, you can go ahead and assign a uniform pressure to it and then distribute the pressure. If you are interested in changing it, the default way for a panel to distribute its loads is in 2 directions. You can see here for my particular model, I have a one-way distribution since I have a quite rectangular area. So I can go over to this panel area to navigate to the appropriate spreadsheet. And to change that, I'm going to go to the panel loaded edges area. You can see I unselect certain edges. So to reselect, you can see here what that basically creates for you as well. So now that we've gone over the different types of load items, basic loads that are available, let's also discuss some load combination information. Now we do have load combination generators that are available within the STAAD.Pro Physical Modeler. Now, just like in the analytical modeler, you can create your 2 different types of load combinations as needed. You can create traditional load combinations, which would be most appropriate for a linear elastic analysis, or you can also generate repeat load cases, which would be appropriate for any type of second order analysis, including any type of P-delta analysis, direct analysis, or also if your model contains tension or compression only members. So what I'm going to do is show you where the option is and also how to access your load combination generators. Now again, I went into this particular topic a little bit more in detail in my last special interest group session. So what we're going to do is we're going to go ahead and specify our model options. I'm going to go to the Data tab in my ribbon toolbar, and I'm going to find this Options area. This Options area can be used to specify your analysis model information. Now here I'm going to get my combination load case information. Now analytical superposition basically means your traditional load combinations. Linear elastic analysis is what that's going to be used for. Repeat primary load cases, what that's going to be used for is to create those types of load cases that will be available to combine loads, add them in tandem, and would be appropriate for a type of second order analysis. Now when you generate repeat primary load cases, you're also able to incorporate notional loads in that in preparation for at some point doing a direct analysis. Now the way the load combinations work within the physical modeler is you're going to go ahead and select that as an analysis option, and it will apply that different analysis option type to your entire model or all of the load combinations that you created. So let's go ahead and review the load combinations that this particular model has. Again, I'm going to use my spreadsheet area to go or navigate to that spreadsheet. And I'm going to go to this load combinations area. And for my particular model, I can see all of the load combinations that I've already created. Now, since I've selected that repeat style load cases, when I translate over to the analytical modeler, it will generate those as repeat load cases. I also like to show, however, how to know what load combinations will be generated. So you can basically review them. I think for any structural engineer using any piece of software, you should always thoroughly review your load combinations and make sure everything is as you had intended it to be designed, incorporating everything you were looking for. So to access that information, we're going to go to the Model tab in the ribbon toolbar. Again, your Model tab is where you're going to go to basically add information to your model, to model certain items, to generate load combinations, to create load cases, and then eventually return to your analytical modeler. You can see here I have two different options. Load combination, that's if I want to create my own load combination. Maybe there's, for whatever reason, the load combination generator is maybe doesn't have everything I need or I'm looking for. I want that custom ability, that manual option. I'm going to use load combination. Or I can go to my automatic combination area where the load category will be utilized in order to generate those load combinations. Now what I'm going to do within this dialog, again, my model already contains this information, but I want to click on this Manage Rules area where you'll get more information on what will be created. Now by default, when the Manage Rules comes up, it's going to come up with the load combination generator I had selected in that dialog, which for me was the AISC 360 2010 code in the public area. Now here I can see all the different load cases that will be picked up through this load combination generator, and I can see the factors that would be assigned to them. If I wanted some additional information, because I know that this looks a little bit different than the analytical modeler, I can double click on this configuration option, and what it'll do is it'll give me that additional information for nodal load information, or I should say notional load information, and the combination type. So here you can see that kind of information that we're used to seeing in the analytical modeler. This will be where the program knows which types of load cases are appropriate to be incorporated with a notional load, and also the combination type. Aggregate means that if you have two different load cases, say for example, that are assigned to the dead load category, those two load cases are added together. If you see separate, basically that means that those, if I have two different load cases with the same category as say wind or seismic, they would be separated into two different combinations and not be added together. So here I can see all that information before I generate the load combinations. Now, since the STAAD.Pro Physical Modeler enters this information in a series of spreadsheets, these also work very similar to Excel, where you can kind of highlight the fields. If you want to delete something, highlight them, delete them eventually, if for whatever reason you decide you want to go a different route. Now, the last topic we are going to discuss today is how to consider our load definitions that are currently available in the STAAD.Pro Physical Modeler. Now, as I mentioned, I do recommend if you're getting to this level of loading in the Physical Modeler that you upgrade to the latest version of the software, which right now would be STAAD.Pro Connect Edition, version 22, update 5. Now, the workflow for incorporating a load definition into the STAAD.Pro Physical Modeler, I like to think of it as basically a three-step process. You're going to create your load definition with your code variables, say for seismic or wind. You're going to create a specific load case to house that information. And when I'm looking at category, I'm looking for something that says definition at the end of it. Because if you want to, we don't know if you want to create your own manual seismic loads or if you want to utilize a definition. So if you see seismic general, that means you're creating your own load case. It's going to be assigned the seismic category. It's going to be incorporated into load combinations, but we're expecting you to create the nodal loads or member loads that you hand calculated. When you say seismic definition, it means that you want us to grab the definition that you created. And then the last thing is we do have a few options that are applicable mostly for the dynamic analysis types that are available. Again, you want to go to that analysis options page. That's the same tool that we went to for specifying our load combination information. Let me just show you where some of that information is housed. Now, again, I know this is a lot of topics to include in one special interest group session, so this is my overview of options available. If you want more information on any of these topics, again, we will be having training very shortly, and I would encourage you to kind of sign up for a step-by-step training session where we'll go through all the different options, the same way we do for the training options available for the analytical modeler. So our first step would be to set up your definition, which we're going to go to the catalog area. As you can see, I have a few definitions already created. I can go up to these tools to create a load definition. This first tool adds seismic. This would be to create a static seismic load, an equivalent lateral force procedure seismic load. The same rules hold true for the physical modeler as they do for the analytical modeler, meaning you can only have one seismic definition for a static seismic load in your model. So we're going to just create one in that scenario. We have response spectrum and time history also available. For my model, I created a response spectrum option. And then we also have new for update 5, we had some add wind loads. Now the wind loads do have a few limitations associated with them. You are able to put in your code loads. You are able to generate, design wind pressures for both enclosed and non-building type of structures. But the way it currently works is you can only add one load definition at a time. So think about that. Again, I want to make sure that we understand the full capabilities and the differences between the way the physical modeler approaches things at this present moment and the analytical modeler. Let's go ahead and take a look at one of these options. So I'm going to go ahead and double click on it. Double clicking will allow me to edit one that I've already created. And you can see many of the inputs here look identical to the inputs that we would enter in the analytical modeler. The one major thing that I see slightly different between the analytical modeler versus the physical modeler is how torsion is considered. Here you're going to enter more torsion information directly in your load definition, whereas in the analytical modeler you'd enter some of that within your load item. And again, we have a response spectrum, and for me, I also created a couple different wind loads. Now, although we can't necessarily at this point add in different wind load definitions within the same load case, you can combine them together in a load combination. So keep that in mind, that there are some workarounds available. It just might be a slightly more manual process than you're used to, okay? So that would be step one. You're going to set up your code variables, very similar to as we see in creating a load definition in the analytical modeler. Then what we're going to do, again, we always go to the modeling tab when we're creating data, creating new load cases. So if I were to create a new load case for one of those options, I'm going to come here, create a load case, not a load group. These go, wind and seismic go in the load case sections. And again, you're going to look in your category field. So say I wanted to do a seismic definition, and then you'd say which one are you grabbing. It's going to know which one because you're only allowed to have one for this example. And you can enter its direction and its factor. Now, if you want to review that information, I know we went to the load cases spreadsheet, and here I'll go there again. I don't see it here. So one of my goals was to show you where you can find that information through the product. And you can see these different reference areas, and some of these icons look very similar to what we just saw on the catalog page. So basically what they do is when you assign something to a category, that's basically something and a definition, maybe a response spectrum or a seismic definition or wind definition, they go in a separate spreadsheet. So here we can see, here's my response spectrum load cases. So here we'll be able to see what's been added in the model and their factors. Once you create that load case, you can adjust your factors. Here I can go to my seismic load case. Here you can see I grab my definition, and I'll be able to see which directions they're acting. If I wanted to, I can create additional load cases for the negative x direction, or also consider things like eccentricity a little bit further. And then finally, I also have one for a static wind load case. You can see I created two different ones. I just did windward and leeward wall for this particular example. Now, these types of items, most of them, I believe, static wind and static seismic, will be also able to be incorporated into your load combination generators. Okay, so we can go ahead and see that information. And again, if you have any dynamic loads, you can work on setting up your number of mode shapes through your options area. So here we have a tab for dynamics to basically set up any additional information that might be necessary for those types of load cases. Now at this point, what I'm going to do is let's go ahead and return to the analytical model so we can see basically how all of this information gets translated over. So we're always going to want to save our model, and then let me go through the main path. We have it in the quick access toolbar up here, but in case you don't like using that, we can go ahead and return to our analytical modeling mode. Every time you return to your analytical modeling mode, it's going to rebuild your input file. Now, for that reason, anything between geometry and loading in your input file is grayed out, meaning you don't want to edit it in the analytical modeling mode. I'll go ahead and discuss certain things that might be important for that type of option, but let's go ahead and go to the analytical modeling mode. And let's access our loading areas. Now the first thing I'm going to do is I'm going to expand my definitions. Here you can see wind definitions were created. My physical model had 3 different wind definitions. I can see my mass reference load here. I can review that information. You can see here, I can see all my load arrows and everything. I can see my seismic definition that I created. All of this is translated the way I would like. Now, static seismic loads. Now, it is a program requirement that static seismic loads, if you're using a load definition for them, appear first in your load case details list. I know probably many of you who are used to that workflow are used to doing that in the analytical modeler. In my physical model, I did not create my static seismic loads first. I actually created them towards the end of my workflow. Because we use those different spreadsheets to populate different data, and I assign these as a seismic definition, it automatically puts it first in the list for me. So that's something I don't have to necessarily think about when I'm using the physical modeler. So the static seismic load appeared first, and then everything else goes after that. And here I can review the information. I can review the load combinations that were brought over. I know that these are repeat load cases because I have my red L adjacent to them. If they came over as traditional load combinations, I would see a blue C next to them. That's kind of your indication where you can see after the fact what was created. Now let's go ahead and go over to our analysis area. Now again, we are going to include blocks of data that says do not edit between these particular areas. That is the inputs file designation to say anything within those blocks of data you don't want to edit. The reason for that is because the next time, if you go back to your physical modeler, make changes, come back to your analytical modeler, everything between those do not edit blocks, there's one at the bottom and there's one at the top. Anything between those different pieces of, oh, here we go, start, do not edit. Anything between those two different blocks of data will be recreated every time you come back over to the Physical Modeler. Now, there are times where you need to, if you, and for my particular model, it actually would be necessary, where you may need to perform an analysis on your static seismic load cases individually. That can sometimes be required to do a multi-run analysis when you are using those seismic load cases later on in a repeat style load case, which I do have in my particular model. Now, if I needed that, I can go ahead, just as I would normally do, add a perform analysis and a change command in between those seismic load cases and the next load case that follows, same as I would in the analytical modeler. One thing to note, though, is if I rebuild my analytical model, those commands would be removed because, again, it rebuilds that whole block of data. Okay, so just keep that in mind for that type of workflow. I do believe at some point in the future that workflow might include analysis, but at this present time it does not. So just letting you know about that. I do have after here a perform analysis command that would not be removed during that process because it becomes after all of your load cases or combinations. And so that's safe, that won't go anywhere. And then for my particular model, I didn't do the whole design process, but I did go ahead and assign a steel design code and a code check command as I typically would for my workflow. So geometry through loading is created fully in your physical modeler. Analysis and design is added in the analytical modeler. The analytical model will then be analyzed and designed, and then you can feel free to go access the post-processor or other versions of the program or post-processing features such as like RAM connection, for example.